In this video, we'll take a look at raising complex numbers to higher powers. We'll keep those powers as integers, but we're going to raise them to higher powers, and this makes use of de Moivre's theorem. To raise a complex number to a power, we may use the exponential form of a number along with the properties of exponents. And remember that if you have a base a to the m, and you raise that whole value to the power of n, then you multiply the exponents, right? We multiply in here, that becomes a to the m times n. Well, by raising the complex number re to the j theta, we want to remember that that n exponent is on the r, so we get r to the n, and it's on e to the j theta, and when j theta is already raised to a power, so you multiply those powers, so it's j theta times n, or e to the jn theta. In trigonometric form, what this will look like, we've got r times cosine of theta plus j sine theta, all to the power of n. What that means is we will raise r to the power of n, as we see here, and then multiply the angles by n. And the same goes for the polar form. We'll raise r to the power of n, but multiply the angle. And actually, you can see this if I take an example of, let's just take an example of 4 at an angle of, let's do 10 degrees. And we're going to square that, okay? So that's the same as 4 at an angle of 10 degrees times itself, 4 at an angle of 10 degrees. And you remember with the multiplication rule, what we did was we multiplied the r's, and in this case, they're just the same number. So we've got 4 times 4, or 4 squared. So I have raised the 4 to the power of 2. And then what did we do with the angles? We added them. So I've got 10 plus 10. Well, that's 10 2 times. So 2 times 10. So that becomes 16 at an angle of 20 degrees. Okay, so it still follows the rules of multiplication, but raising numbers to higher powers is like quick multiplication. So here's an example of raising a complex number to a power using de Moivre's theorem. Now, I've got 4 plus 5j, this is a rectangular form, to the power of 6. Now, de Moivre's theorem is for polar form, exponential form, and trigonometric form. So we're going to have it in one of those forms. And right now, it's in rectangular form. So let's just go ahead. We will first change this to, I'll say polar form, okay? Let's just put it in polar form. In order to put it in polar form, we need r and the angle. Okay, so for r is equal to the square root of x squared plus y squared, right? Which is the square root of 4 squared, which is 16, plus 5 squared, which is 25. So this is the square root of, let's see, 25 and 16 is 35, 41. Did I do that right? Thank you for checking. Square root of 41. I think that would be better as a decimal. So let's just go and check for the decimal of the square root of 41. Grabbing my calculator here. 41 square root, 6.403. I could just leave it as root 41, but a lot of people aren't as familiar with radical form, so let's just leave it like that. Okay, we want to find the angle. First of all, before I find the angle, because quadrant's important, right? This is a positive x and a positive y, which means this angle is in quadrant 1. All right, just keep that in mind. So theta is going to be the tan inverse of y over x, 5 over 4. So that's the tan inverse of 1.25. So grabbing my calculator, that gives me 51.34 degrees. Okay, so that means in order to take, let's just change the color for this. In order to do 4 plus 5j to the power of 6, I'll put that in polar form, 6.4, let's use 6.4. At an angle of 51.34 degrees. And we need to raise that to the power of 6. So now that it's in polar form, we can raise it to the power of 6. Remember what de Moivre's theorem says. Take 6.4, raise it to the power of 6 at an angle of 6 times 51.34 degrees. And so this becomes, trusty calculator, 6.4 to the power of 6. Ooh, big numbers, 68,719. I'll just round it to the closest whole at an angle of 6 times 51.34, which is 308.04. degrees. And that's raising complex numbers to higher powers using de Moivre's theorem. Thanks for watching.